Hello, so this is section 3.2. Topic today is long division, synthetic division, and remainder theorem. So before we bring back the polynomials, first let's review just long division without any variables. So the number, just to refresh some of the terminology, the number being divided is dividend, and the number you're dividing it by is called the divisor. So the dividend goes under here. So you have the dividend, you put it in there, and the divisor goes on the outside. So now you just need to see, well, how many times can 7 go into 1 first, which is 0. So then you move on to the next number. Well, how many times can 7 go into 12? Well, that's once. Now you're going to subtract it. So that's 5. Bring down the 0. How many times can 7 go into 50? 7. 49. Subtract it. Bring down the next number. How many times can 7 go into 15? Twice. And that gives you 14. So we're not going to go into any decimals, and we're just going to leave it there. So once the divisor can no longer go into the number, just leave it. So again, we already know the number in here is the dividend. The number out here is the divisor. The answer you get from a division question is what we call the quotient. And that number that is left over is called the remainder. So when you look at the relationship of these four parts, well, the dividend is equal to the divisor times the quotient, and then you add on the remainder. So if we fill it in with the numbers we have from this particular question, so 1205 equals to 7 times 172 plus 1. So with each of these four parts, we kind of short form it with different letters. So dividend, since there's the word dividend and divisor, so divisor got the D, quotient is Q, remainder is R, and dividend, well, P. Doesn't make sense to have two of the same letters. So there's an alternative way of writing this, and which is, what you're going to do is you're going to divide both sides of the division statement by the divisor. So what that's going to look like, I'm going to be using the abbreviated letters. Well, used to be dividend equals to divisor times quotient plus R. Well, if I'm going to divide both sides by the divisor, well, this is divided by D, and the other side is also divided by D. But since I have two things added, I'm going to break it up into two separate fractions, which will actually look something like this. So D's cancel out. If I rewrite it, P over D equals to Q by itself plus R over D. So if I fill it in with the numbers I had before, that'll be 1,205 divided by the divisor, which is 7. Equals to the quotient 172 plus the remainder divided by the divisor. Okay, so two ways of writing the division statement. All right, so let's bring back the polynomials now. So long divisions with polynomials. Unlike the example we looked before, one thing you just have to be mindful of is the situation we're looking at is always a polynomial by a binomial. So binomial just means there are two terms. And both the divisor and the dividend, before you divide the polynomial by a polynomial, arrange both divisor and the dividend in descending order. And what I mean by descending order is you're looking at those variables, and for example, something like this is what you would want. So something to the power of 3, 2, 1, all in order. But if you have something like this, where it's just to the 3 and then you're just adding 1, then you will need to do the next part, which is insert the missing terms using a coefficient of 0. So if you have just 3 and 1, well, we're missing x to the 2 and x. So you'll need to just add those in, but with a coefficient of 0. So they're just added in, but since there's a coefficient of 0, they don't technically exist. So for example, you'll change it that way, okay? So let's look at our first example. So we have x to the 2 and then x and then some number. So in this particular case, no need to add in any new terms. So now we're just going to set it up like how we did before. It's 8x plus 9. And then we're going to divide it by our divisor. Okay. So this time, same thing. Well, look at that first term. How many times can 2x plus 1 go into, you'll need to look at these two terms together. So, but we're always just going to get rid of that first term. So we want to get this first term in the binomial to be equal to this first term in the polynomial so we can eliminate it. So we want, how many times can 4x squared be divided by 2x? Well, you'll need to multiply that by 2x. So now you're just basically multiplying this binomial with this here. So 2x times 2x is 4x squared. Plus 1 times 2x is plus 2x. Going to subtract it. Keep in mind everything here is subtracted. So it's 8x minus 2x, which is 6x. So I'm just going to write this for reference. This part right here is basically the 2x plus 1 times 2x, okay? So next step is the same, bring down that 9, or the number. Now here, how many times, what will you multiply with 2x to get 6x? Well, it's 3 plus 3. So that's going to be 6x plus 3, subtract it, and you have a remainder. Oops, and keep in mind you're not subtracting this whole thing. Now you have a remainder of 6. And I'll just write this as a second note. This part right here is 2x plus 1 times 3. All right, so next part, division statement. So what is the division statement for the polynomial? Again, it's still going to be the dividend. Oops, let's go back to blue. The dividend equals to the divisor, dividend p. Divisor times quotient plus remainder. So in our particular case, we have 4x squared plus 8x plus 9 equals to the divisor times the quotient, 2x plus 3, plus the remainder. Or I guess if you want to write it that secondary way, we're going to have, remember, dividend divided by divisor equals to quotient plus remainder divided by the dividend, which is 4x squared plus 8x plus 9 divided by 2x plus 1 equals to 2x plus 3 plus 6 divided by 2x plus 1. Okay, so two ways of writing out the division statement. All right, let's try another example here. So this time, divide and also identify the restrictions on the variables. So remember, when you're dividing, it's basically also like a fraction. And with fractions, the denominator, which is this bottom part, minitor. Let's just note the top part, refresh your mind, this is the numerator. Well, anyways, the denominator cannot equal to 0, or else you'll have an error. Your calculator will be very upset if you do this, and you won't get an answer. So the restriction in these particular cases is, well, in this particular case, 2m minus 1 cannot equal to 0. So moving things around, once we move, first we'll move the 1 over, divide both sides by 2. We know that m cannot equal to 1 over 2. Boom, let's put that restriction in a box. All right, now that we got that set, well, next, looking at our dividend, which is this top part. Sorry, I'm writing a lot of stuff here. This top part, we could also rewrite this as 8m3 minus 1, this whole thing divided by 2m minus 1, right? So this first part is our dividend. And when you look at it, well, we're jumping from m to the 3 straight down to no variables. So this is where we need to do that thing where we add in our missing terms. So we have 8m to 3, we're missing m to the 2, so add 1 with no coefficient, or 0 coefficient. We're also missing m. Now we're at 1. And then we're gonna go with, now we're gonna stick our next term in here. Oops, 2m minus 1. Now we just follow the same thing we did before. So looking at our first two terms, well, 2m needs to multiply what to get 8m3? Well, that's 4m2. Multiply it in, 8m3 minus 4m2. Now remember, we are subtracting this. If you're subtracting a negative, that becomes a plus, so that's 4m squared. Bring down the 0, plus 0m. Now, 2m times 2m will give us 4m squared minus 2m. Now again, we're subtracting a negative, so that's basically 2m. Now bringing the last part in, minus 1. Well, 2m minus 1, we're left with 2m minus 1. Well, just multiply that by 1. Okay, and here we're left with 0. Okay, so that is what we have here. All right, so now that we've looked at long division, we're going to move on to something called synthetic division. Now, this is just kind of a different way of doing the same thing. So in this particular case, you're dividing a polynomial by a binomial in the form of x minus k. So be very careful here. This x has a coefficient of 1. So if it doesn't have the coefficient of 1, it won't really work. Then you'll have to go back to long division, okay? So we're just, there's kind of a couple steps here. First step is you will be setting this up in an L bracket. So it's gonna look like so. Then you're going to write the coefficients of the dividend in order of descending power. So I'm just gonna write here, the coefficients I'm talking about is this number up front, include the signage, okay? So these are the numbers I'm going to write. So here is 4, negative 11, 8, and 2. Next, you're going to, on the left of the L bracket, on the outside, copy the constant term of the divisor. Maybe I should note that down, of the divisor. So you're writing down that number right there. So if it's negative, you'll put a negative. In this case, it's a positive. So I'm just going to write 2. And then next, you're going to bring down the first coefficient below the L bracket. So this number right here, just bring it straight down. Okay. And the pattern that's going to happen here is anything that is happening kind of in between this box here, you're always going to subtract it. I'll just write that there as a note. And the relationship is you're always going to multiply, you're going to multiply this number below and then write the number over here. So multiply with the numbers below and write the numbers inside, subtract, multiply. Anyways, you'll see how it goes. So first, 2 times 4 gives us 8. Negative 11 minus 8 gives us negative 19. Okay, so now 2 times negative 19 is negative 38. So negative 38, if we now subtract it, here will be, 8 minus negative 38. Keep in mind, there's a minus negative. That's 46. So 2 times 46 is 92. 2 minus 92 is 90. Okay, that's synthetic division. Now, so we've done this math. Now, what does this mean, right? So here is basically our quotient. Okay, I'm just going to leave it there. And this number here is our remainder. Oh, sorry, missed a negative sign here. Okay. So with the quotient, you'll just need to look at, well, oh, this should be to the 3. Sorry, missed that there. Okay, so with the quotient, you'll just need to look at the initial kind of degree, and you'll need to subtract 1 degree. And these are basically your coefficient of your quotient. So it's always going to be 1 less. So the quotient is basically 4x squared minus 19x plus 46. And our remainder is simply the number you see there, which is negative 90. Okay? And that's how you solve synthetic division. So let's look at another example here. So we have given this particular function, determine the remainder when it is divided by x plus 1. So basically here is our dividend, here is our divisor. Now again, our dividend, we're going from x to the 3, x to the 2, we are missing an x, so we will need to add it in. So we're going to solve it both by long division and synthetic division, and you'll see that, hey, 2 ways of doing the same thing. So we are missing an x, so let's add that in, plus 4. And this is divided by x plus 1. Okay. So x will go in, we'll multiply x times 2 to get x negative 3. 1 will be plus x squared. Subtract this thing, that'll be negative 3x squared. Bring down the 0, oops, plus 0x. So we're gonna minus 3x to get our 3x squared. And this will be minus 3x. Subtract it. So we have negative minus, that'll be 3x. Bring down the 4 plus 4. So it'll be plus 3. So we have 3x plus 3. When you subtract it, we're left with 1. All right, let's look at synthetic division. So same idea as with long division. You still need to fill in that 0 coefficient if it's missing. So we have 1, negative 2, 0, and 4. And the number that we have as our divisor will be the plus 1. So first, bring down the first number, 1. 1 times 1 is 1. Negative 2 minus 1 is negative 3. 1 times negative 3 is over here. So 0 minus negative 3 is 3. 1 times 3 is 3. 4 minus 3 is 1. And as you can see here, remember, here is our quotient. So if we write that, that's basically x to the 2, since we had a degree 3 to start, minus 3x plus 3. And we have remainder 1. Hey, that looks exactly the same as what we had in long division. So both ways will work. It's kind of your preference which way you want to go. Okay. All right. So division statement. Okay, let's rewrite this guy out. So dividend is x3 minus 2x. When you're writing the division statement, you can take out that zero coefficient term. Okay, so plus 4 equals to divisor x plus 1. Quotient is x squared minus 3x plus 3. Remainder is 1. All right, so right now we're just going to make a small observation before we jump to the next step. So what happens when you plug x to the negative 1 into both the left and right side of the above equation? Well, let's try that. So if we put it into negative 1 minus 2 negative 1 squared plus 4. So here is our, let's just actually separate it out here. So here's our left side, and right side is basically negative 1 plus 1, negative 1 squared minus 3, negative 1 plus 3 plus 1. Okay, let's just start with the left side. So negative 1 to the 3 is just negative 1. Negative 2, negative 1 squared is just 1, so it'll be negative 2 plus 4. Why is there a random bracket there? Plus 4. So here we have negative 3 plus 4, which is 1. Now on the right side, let's see, negative 1 plus 1, that's basically 0. So, well, actually, 0 multiply anything would be 0, but let's just calculate it out. So we have 1 plus 3 plus 3 plus 1. So this part in the front, anything multiplied with 0 is just 0 plus 1 equals to 1. Okay. So what happens here? Well, it seems like when we put in this negative 1, well, we get this 1 as a result. And where have we seen this 1 in this previous question? Well, the remainder. So, and where would this negative 1 have a relationship with? Well, maybe with this divisor here. So there is a relationship there between our divisor and when we put in the number and the remainder, which leads us to the next part. So when a polynomial function, px, is divided by k or x minus k, the remainder is equal to the value of the polynomial when you plug in x equals to k. Okay? Okay, and this thing is called remainder theorem. So looking back at the last question we just looked at, so it's saying the polynomial function is divided by, or when it's divided by x minus k. So in our case here, that number was x plus 1. But if you look at this as x minus k, then that k value is actually negative 1. So if you plug in negative 1, because remember maybe if I write this down, the divisor is here. And this thing, if you think of it as x, if you think of this as x minus k, then that means k must equal, why am I writing that? Must equal to negative 1. So if we put in that negative 1 back into our equation, well, we see that the output is our remainder. So let's just put that into, let's try these in a couple of our examples now. So when find the remainder of this particular function when it's divided by, first, x plus 1. So remember, x plus 1, we need to think of it as, to find the number we plug in, we need to remember it's x minus k. Now, please don't confuse this k with the k we used in transformations earlier, okay? We're not talking about vertical translations here. K is just a letter that we so happen to use here, not the same k though. So in this particular case, since you have to take the negative, so k is equal to -1. So let's just plug it in. So p, and then if we put in -1 to the situation, so we have 6, -1, 3, minus 4, -1, 2, plus 8, -1, plus 6. So let's just figure this out. So it's -6 minus 4, minus 8 plus 6. So the 6's basically cancel each other out, so we're left with -12. So we know, even without having to do long division or synthetic division, just by simply putting in this number into the function, we know that here, if we divided this by x plus 1, our remainder is -12. All right, and I'm gonna actually save the next two for you, but I will get you started for this next one here. Again, remember, if you think of this as x minus k, that means k must equal to 2 in this case, so you can figure out what the remainder may be. Now the last one here, just scroll down. So with this one here, remember, we do need, how's it going? X minus k. But right now, we don't have x by itself. So we will need to, let me just write this down, x minus k. So we will need to divide everything by 2 to get it down to just being x minus k. So that basically becomes x minus half. So once you've done that, apply the x minus k, so we know k equals to half. So that's all I have for you today, and good luck finding the remainder.